Okay, we've been talking about all of these different ways that things can affect our weather. But what we haven't really talked about is how exactly do we get weather on this planet? What is the driving force for weather on the Earth? And you can basically think about it that there are a lot of concepts that we've talked about that are going to come into play in explaining how we get weather. So it has to do with heating and that unequal heating of different surfaces in different areas on the planet is what leads to all of these different things that we see, such as storms and wind and precipitation and cloud formation. That all has to do with different amounts of heating to different surfaces. Because we know that the energy for that comes from the sun. And we know that the unequal heating is caused by several things, that the Earth's surface is curved so that some areas get focused energy from the sun and some get spread out energy. We know that the Earth spins so that energy is on different parts of the Earth throughout the day. And we know that the Earth is tilted, which will also alter the amount of daylight and the amount of focused daylight that areas receive throughout different times of the year. So the sun producing heat on the planet and the planet altering the varying amounts of heat on different parts of the planet are things that lead to wind and cloud formation and storms and um, whatnot as far as weather goes. So let's get more specific about the three things that allow that energy to move around that cause weather. The first is radiation. Now, radiation is the energy coming from the sun, and we're fortunate in this case that radiation requires no media to travel through because there isn't any water, there isn't any air in space. So, fortunately, that radiation can travel from the sun and reach the Earth and begin the whole weather process. The second is um, again, radiation is without contact as well. So, conduction is something that requires contact basically between molecules bumping into each other and transferring energy. So if the surface of the Earth heats up, it's going to, those particles will move more. They'll come in contact with the particles in the air and transfer that energy to the air. So it requires contact for conduction to work. It's the same concept. If you have a metal leg on your chair, you hold that leg and it feels cold compared to your hand because it's conducting heat out of your hand and into the chair. It's the same reason why you have to use a hot pad to pick up a metal tray out of the oven because it's going to conduct heat through that contact to your hand. Now, the last one is our friend convection, which we've talked about lots of times. So we have the heat coming in from the sun, heating up the surface, the conduction causing the air above the surface to warm up. And we know that warm things will do what? That's right, they will rise. So that warm air will rise until it cools and loses energy and then come back down, and that circulation of energy. And all of these things put together create all of the weather that we have. So again, radiation requires no contact, conduction requires contact, and convection is the circulation of that energy. And all of these things lead to the weather that we have: wind, precipitation, storms, cloud formation, etc. All of that thanks to energy from the sun circulating in our atmosphere through this process. All right, so what you're going to do in your assignment today is you're going to look at several examples and determine whether or not you're looking at radiation, conduction, or convection. All of the examples are attached to your assignment. Please fill out that complete table and the back of the worksheet as well. Good luck.